So now let's have a look at how would you determine the dip angle, okay, and also the strike and so forth from a map by drawing in and looking at the strike lines. Let's again draw a very simple example with two sets of contour lines, and again I like it, so let's call it 200 and let's call it 100 in this case. And then again we can draw in some geology. We've got a contact here and we've got another contact there. So we will then of course go and draw in the strike lines. So let's draw in the strike lines for the blue unit, okay, and the strike lines for the blue contact would be this here, and you would of course have another strike line there. Okay, so how will I use this now to determine the strike and the dip angle of these rocks? Well, the first important thing that you will probably have in your map, as I said before, is a north arrow. So what you can do is to determine the strike, you can go and look at the intersection of the north indicator on your map with your strike line, read off the angle, and that will be your strike. And of course at 90 degrees to your strike will be your dip direction. And that's the first thing. The second thing of course is that on your map you will have a scale, okay, whatever that might be, and you will have to use your scale to calculate the following on this map. Now to be able to do this you will have to use some basic trigonometry, and we have to think about what we're seeing here in the following way. Let's draw in well, let's do it like this. What we see is something like this. We see one, oops, let me use a different color, one strike line over there, okay, that's a strike line at 100 meters. The other strike line is situated up here, that's a strike line at 200 meters. But what you will see is that there is a distance between these two strike lines, and that distance is represented by this distance here. So that's the first thing that you have to work out from your map by using your scale. What is the distance, the horizontal distance between the two strike lines on your map? Okay, so that will give you some information, okay, which you can use. The other thing that you know is you actually know this side of this triangle, because that is the difference in the contour heights between the two strike lines, and that of course will be 100 meters. Now the other thing that you have to realize is, if you look back at your school mathematics and things like that, that if you've got two lines which are parallel to each other, okay, there's certain relationships between the angles. Now the one thing is we want to know what is the dip angle, okay, that's what we want to know. But because this line and this line are all at the same elevation, they are parallel to each other, which means that this line or this angle is the same as that angle. Therefore you can use very simple trigonometry to calculate what that angle is, because you've got this value, okay, which gives you this side of the triangle. You've got this value, which is the difference in the contour heights, which gives you this side of the triangle, and of course you want to know what that specific angle is, and you know that that is 90 degrees. So I'm not going to go into the formulas, it's very easy, but that is how you would actually calculate the dip angle and the strike of these rock bodies. Now of course already, because you can see this relationship, you know therefore that these rocks are dipping towards the south, therefore your dip direction would be like this. Okay, so in this case, if you measured off your strike, and the strike was, let's call it 80 degrees, you will have to plus 90, which will make it 170 degrees for your dip direction. So in the end it will be 170 slash whatever that is in degrees for dip direction as well as the dip angle.